Alrighty, welcome to the very last video for Chapter 8. This is a bonus topic. It's actually it's still in Section 8.9 of the textbook, but they covered two different things in the same section, and I thought it was best to kind of separate the videos since they're really two different techniques. So this one is all about solving equations by taking a square root and branching. So we previously learned about absolute value problems and how to branch those. So there's no new vocab, but we're going to learn how this is similar to the absolute value problems. This is useful when you have an equation in the form of something squared, so you get this stuff here squared by itself on the left-hand side, and then you have on the other side of the equation something like a number, hopefully in just a single numerical value. So to work backwards on PEMDAS, you can undo squaring something by taking the square root of both sides, and you need to branch. Okay, the reason you need to branch is because when you square a number, it doesn't matter if it started off positive or if it started off negative, they'll both end up positive. So for example, if you have stuff squared, let's just call it x squared equals 9, what number could you put in here that would work? Well, you could put x equals 3, of course, but you could also put x equals negative 3, because it doesn't matter whether it's positive 3 or negative 3, when you square it, it will still get 9. So you're going to branch to each of these, and you're also going to take the square root. So the two branches you're going to get are whatever you had here equals a positive square root of n, and whatever you had here equals a negative square root of n. So it's almost identical to absolute value branching, but you also have to take the square root when you branch. Whereas with absolute value, you just put whatever stuff was inside the absolute value bars equals positive or negative of the other hand side of the equation. So this is just like absolute values, that's what I said. Step 1 is to always get the squared part by itself, and then step 2 is take the square root and branch. And then lastly, of course, just like absolute value parts, you can't take the square root of a negative number, just like the absolute value can't be negative. So if you do have something squared equals a negative number, then your answer is immediately no solution, because something when squared should not come out to be negative. I can tell you a secret, actually. When you cover this later in Algebra 2, or maybe in this year for honors or something, you'll actually learn that we've created a whole set of negative numbers which allows us to do this, but that's a discussion for another time. Let's get to the examples. Solve each equation and check the solutions, okay? So in this one, it's equal to 0, so we think we might want to use the zero product property. So let's try to factor it, okay, using the information we've learned in the previous sections. What two numbers multiply to 81 and add up to 18? Well, it turns out 81 is a perfect square. It's 9 times 9. Okay, and 9 plus 9 is 18. But it's a negative sign, so our solution will be x minus 9 and x minus 9. And because of the zero product property, we can immediately say the answer here is x equals 9. And the answer here is also x equals 9. So it just so happens that even though technically there's two answers, they're really the same answer. Okay, let's try this one, because this one's a little more robust. Now, we have a squared part here. There's no common factor between a 4 and a 17, but the part that's squared, there's only a single variable. Let me go back up here. What made this one tricky is we had a variable in two different places, so we couldn't get the variable by itself. But in this problem here, we have a variable in only one place, so we can actually isolate the variable by working backwards. So we can add 17 to both sides, plus 17. Okay, when we do that, we're going to get 4n squared equals 19 plus 17 is 36. Then we can divide both sides by 4. Then we're going to get n squared equals 36 divided by 4. That's going to be 9. Then we can take the square root of both sides and branch, and we get n equals 3. And n equals negative 3. So the square root of 9 is either positive, it's always 3, but you have to take both options. So that's one good example. Let's try number 22, sorry. In this one, you've already got stuff squared by itself, okay? So we want to take the square root of both sides, okay? And that's going to give us the part inside here, m minus 4 equals positive square root of 7. And the other branch is m minus 4 equals negative square root of 7. So in both cases, we want to add 4, and we get m equals 4 plus the square root of 7. You cannot combine these together because this is a square root and this is just a normal integer. Same thing here, plus 4 plus 4. So m equals 4 minus the square root of 7. And these can actually be combined, and we can write m equals 4 plus or minus the square root of 7. So they have the exact same format, just one is positive and one is negative. Then it's pretty common to write the answer as 4 plus or minus the square root of 7. So this has given you a little taste. If this side is needs to be factored, for example, here we have a y squared and a y. You can't get this y variable by itself because it's in two different places. So here you would need to factor first and then take the square root. Here the variable is already factored for you. Take the square root. Here the variable only occurs in one place, so you can just immediately solve and take the square root. Here the variable is in two places, so we had to first factor and then use the zero product property. So a lot of example problems will be done in class and assigned via worksheets, but you should be aware that this is just another tool in your toolkit for solving equations. Alrighty, that concludes chapter 8. I know it was a long chapter, but hopefully you learned a lot and you're ready to apply these techniques.